Hi, welcome everyone. Sorry for not being able to be there today and presenting on behalf of Markus Luczak-Roesch. Unfortunately, there's been a bit of a medical incident, but everyone's okay. But unfortunately, he's not able to attend today. So I'm going to give you a short overview, unfortunately, of the work that's done in this paper. The slides that you'll see today are more of a motivational set of slides rather than a detailed insight into the paper. But if you do want to know more about it, please get in contact with us, and hopefully we'll be able to answer some further details about the content of the paper. So I'm going to start with a bit of a motivational piece of why we did the work that we've been doing and where it all comes from. So both myself and Markus work on a large project looking at the study of social machines, and this phenomena is this idea of how do we understand the new phenomena of the interaction between humans and computing, computers at scale, and specifically on the web. So where machines do the administrations and humans do the creativity, going by Tim Berners-Lee's definition. How do we understand what these social machines actually do and how they operate, and what's the interactional piece that allows them to work? So the initial piece of this work came from a study of looking at the Zooniverse, and the Zooniverse is a citizen science project, and this is a number of citizen science projects which are related to doing crowdsourcing scientific tasks. So you work in isolation and you perform a task in a crowdsourced kind of way. So everyone, for instance, in Galaxy Zoo, which is one of the projects they have, various of 38 different projects, but one of them is Galaxy Zoo. And this was where an individual would log onto the system, be presented with an image of a galaxy, and they would then, after they're presented with the galaxy, have to classify parts in the image of the galaxy. So is the galaxy a certain shape? Does it contain specific objects, etc., etc. Now, what actually happened when this project was launched, that the actual system required just an individual to do the task. However, the community that engaged with it started to ask for discussion forums to talk about what they were doing. And roll forward a couple of years, there is now an integrated talk system within the various different projects that Zooniverse host. And one of the initial works that we did in this area is looking at how does the discussions from an unstructured perspective, in the sense that no one knows what everyone else is talking about, come together and form new scientific discoveries. And the reason why we're talking about this is that there's various streams of discussions from different individuals within the task system, but somehow they came together using terms which we'll see later in the presentation, and managed to identify objects within their images they were classifying across, which were actually new scientific discoveries, which were then brought forward by the science team that were running the project, and led to a number of peer-reviewed papers. And as we see here, these two graphs here were just showing the kind of discussions, the interactions between members. Although they didn't know they were talking about the same thing, they actually were either using mentions, so they were using mentions of specific image IDs. So these images that Galaxy Zoo used and a number of other projects came from a NASA database. Or they were using tags which were used to identify common features that they were finding within these images, and that led to this idea of sort of a collaborative process of scientific discovery. So in short, as we say in this slide here, we can observe situations when online communications does not happen along explicit social ties, so that being like a friends and follower network on Twitter, for instance. Instead, they're talking explicitly with each other and are broadcasting about the same topic or event. And what we mean by that is, as I was saying with the Zooniverse, they don't actually talk or collaborate with each other initially or any way part through the journey, for instance, but it comes to some kind of purposeful outcome or collective outcome at the end of this. So we then moved on to looking at information cascades. Okay, so we realized these communications, they weren't actually formal communications. They were a form of, if you want to say, information cascade or information propagation. So someone might use a hashtag, or someone might use a keyword or a term, and that propagates through the discussion channels that were happening on Zooniverse and various other platforms. And we wanted to look at how does this information propagate, and how can you take this very context-rich approach, but take the context out and understand the structure, and does that tell us something about the context of it? So look at it inverse. And then we wanted to see, because of the project we're involved in, looking at various social machines, how can information hop from one screen, service to another, something like Twitter to Facebook or to Quora, and how does information combine and diverge? And then again, look at this at scale, at multiple pieces of information. So then the kind of work that we've been building upon is Kleinberg, so looking at the idea of a document stream and looking at how events can be used, and how burstiness can be used as a measure of detecting events. And in many of these cases, the existing work looked at single systems. So for instance, in Kleinberg, looking at your email stream and detecting events or burstiness within these email streams. But we wanted to understand, can you do this across systems or across features within a system, for instance, and collapse them down? So for instance, in this case, there's someone tweeting with hashtags, and multiple hashtags come in, and can we understand how these hashtags interact with each other, for instance? So this came to this idea of social technical computation. So it's the idea of how much capacity is embodied within, or computational capacity is embodied within these information sharing activities that's going on the web. And these are the kind of under the background of this, which was in CSCW this year, is the algorithms of a social machine. So socio-technical being that it's human and computing interacting, but there is some kind of fixed level of ability or fixed level of use features that a system provides. But on top of that, it's the idea that the technology can be iteratively changed or interacted with in specific ways to allow the social to emerge as well. So we're also trying to understand these content streams as automata. So a bit like the fixed state model, can we identify how the patterns of cascades emerge, like Kleinberg did, as a way, as a fixed set of interactional patterns? And this goes now to this idea of the Transcendental Information Cascades, where we reduce all different documents from across multiple platforms or multiple features into one long stream. And as you see there, it animates, they're multiple streams, but they're one stream, but they can be represented in multiple streams as well. And just a bit of the background too, as I was saying before, how hashtags combine or diverge, and this is what we model, and you see more of this in the paper. So one of the things that we wanted to do then is, can we build matching algorithms as such to identify the patterns or the interactions between these divergence or convergence of information cascades, and applying, as we'll see a little bit further, matching algorithms to various different patterns will change the way interactions or the network structures emerge. And this is a little bit more of the detail, which is probably in the paper if you have a read. So this, I mean, for illustration here, is this idea of the document stream being here in the Zooniverse is each Sankey stream. So each stream going from left to right represents a tag within the discussions, and the kind of divergence or convergence of multiple tags is where they're being used in a post. So for instance, someone might say X, someone might say Y, and then at some point in time, X and Y is used in a single post, and that's when you see the post coming together. And so we acknowledge that in the background of this, there is a lot of work going on in the temporal text data mining area of how they bring together multiple streams of data, and so we built upon this for some of our methods as well. And as I said here, depending on how you construct it, depending on how you do the matching algorithms, will change the way the, as you say, reality or the structures emerge from the text. So we have various different matching algorithms, which are again further described in the paper, and how they change the way the structure emerges from some of the Zooniverse data that we looked at. And this then affects obviously what do you look for, what you're matching changes the way these information cascades emerge, and the kind of patterns or structures that emerge from this. And the arrows you see representing in and out represent the way nodes or parts within the cascade are connected with each other. So if an arrow is going straight in to straight out, like in the left one, number 4, it represents data's come in and into the node, so it might be a hashtag AB, and when it passed along to the next chain, it lost information. It contained the same information. Whereas if you look at something like 10, the arrow in and 2 arrows in basically means it gained information coming in while also having the information from the previous one, as well as it lost information to another source when it was pumping it out, but also passed it on to another cascade with the same. And here we see the entropy when we construct cascades using various different matching algorithms change dependent on the type of matching algorithm that we use. So the final kind of thing we'd like to talk about is, can the cascade motif, so the structure of the cascades, provide an information state, so a state of information. So if you take a macro level perspective, you aggregate up and start to look at the structures, the substructures within these information cascades across time, do they tell you something about what state the cascade is in, and can they predict something about how it could potentially evolve in the future? And this then goes into the formalization of these cascades at any point in time. So finally, just to finish, is as we say here, the coincidence of these informations actually are providing some purposeful output. In the case of citizen science, it's providing new scientific knowledge discovery. In the case of, for instance, social networks, it might be the discovery of new news. And we want to try and understand this and take our approach that we've been doing now to larger sets of data, to various different streams across platforms, to see if that can be shown across networks and across different systems. Again, so thank you very much for today. Sorry we couldn't be there, but hopefully this provided you a short overview. And hopefully if you have any questions, please email any of the authors and we'll be able to respond to you as soon as possible. Thank you very much. Have a good day and enjoy the rest of the conference.